All right, algebra kids. We're beginning a chapter today on something called factoring. Factoring is a topic that is very important as you start moving toward higher mathematics. Much of what we do is in factoring. In fact, there's tests over there at Highline when you get to Highline that you'll be taking. That factoring is a big part of that test. So we're going to talk about what it is. Well, the word factor itself means two things get multiplied together. When you multiply them together, that's called a product, and each of these things is called a factor. These are factors. Things that get multiplied together are factors. So what's really happening here is that we're going to be doing a lot of division. That means kind of working backwards. If I give you a number like 18 and ask you to find all the factors, you're basically going to be spending a lot of time dividing. And we did this a couple weeks back, way back in end of March, where we talked all about factoring. If you did not do those assignments back there in March, you may have to go back and do those so you understand what we're doing here. But if I asked for all of the factors of 18, I know that 6 and 3 are, but there's a lot of others. And one of the things that we're going to have you practice do is listing them in order from least to greatest. So we know that 1 goes into everything. And if you take a look at that divisibility list that I gave you back in March, that'll help you to remember all of these rules. Please go back, I mean it, please go back and look at those divisibility rules. 1 goes in, and it goes in 18 times. Remember, we're talking division here. 2 goes in because 2 is even, or excuse me, 18 is even, and 2 goes into 18. So 2 goes in 9 times. Notice the way I'm writing this again. I'm writing it sort of one at the beginning and one at the end. 3 goes in, and we know that 3 goes in 6 times. 4 won't go in, 5 won't, 6 does, and I already got 6. So there are the factors of 18. We wanted to find all of them. And if you don't find them all, you may end up missing one that's extremely important. Also notice that these factors create a rainbow when you find them all. Now that's not always true though. Sometimes you get a perfect square like 36, where the square root of 36 is a number in the middle, 6 times 6. So 1 goes into 36 times, 2 goes in 18 times, 3 goes in 12, 4 goes in 9, 5 won't go in, 6 does go in, and that's it's multiplied times itself. So here's a set of factors, but this little rainbow that we create, 6 doesn't have a mate. So when this is a perfect square, that rainbow will not occur right in the middle because it's a perfect square. Now the whole idea here is we're looking for all of the factors of a number. I'm not going to spend any more time on this. This is something that we went through back in March. We're gonna move on to something else here. Okay. All right. Sometimes coming up with all the factors of something is a little harder because the numbers are bigger and they're just not on our multiplication table. Here's a number that's not on your multiplication table. -140. So one of the techniques that we can use, and you've seen it before in the past, probably 6th grade and so forth, is this thing called prime factorization. And what we do is we look for all the prime numbers. Now prime numbers are any number that a number is prime if it's divisible by 1 and itself. So we're looking for all the numbers that go into 140 that are prime. Okay, so what I'm going to use is a technique called repeated division. Since this one's negative, I'm going to start with a -1 just to get that out of the way. -1 is one of my factors, and now I'm looking for a prime number, not 10, not 14, but a prime number. Well, a good place to start here would be 2. 2 goes in 70. Pick another prime number. Well, 7 goes in, and that's a prime number. 7 goes in 10. 10 was not prime yet, so we're not done. 2 goes into 10 5 times. And so the prime factorization of this is found when all of these numbers on the outside are prime numbers. and these are. So we would write the prime factorization 1 times 2, there's 2 of them, squared then, times 5 times 7. This is the prime factorization. Sometimes we use this technique when numbers are big, or we have to find the greatest common factor of a bunch of things, which is always a challenge. Go back and take a look at this section on prime factorization. It's in your book. It's also back in the material we covered back in March. Now let's take a look at the greatest common factor. Okay, let's take a look at this idea of greatest common factor. Many times we will use this to figure out what number goes into both of these. And sometimes the situation is like this first one, where the greatest common factor happens to be one of the numbers. And what we could do is we could just start listing all the factors of each of these. Well, all the factors of 12 would be 1 and 2 and 3 and 4 and 6 and 12. And all the factors of 6 are 1 and 2 and 3 and 6. And the greatest one is the one that's in common to both. That's the biggest one possible. There's several others here, but the largest one is 6. So sometimes the greatest common factor is one of the numbers. Now sometimes the greatest common factor is not one of the numbers. So let's list these again here for 30. Okay, 1 goes in 30 times, 2 goes in 15, 3 goes in 10, 4 doesn't go in, but 5 goes in 6. I'm out of room there. 12, let's see, 1, 2, 3, 4, 6, and 12. Oops, 12. So one of these numbers is, we want to find the greatest one. Well, again, it looks like the biggest one that's in common here would have to be 6. Now, sometimes you could just tell by looking at it, and that's good, okay? How about this one, the greatest common factor of 40 and 39? Well, sometimes it doesn't have a common factor other than 1. So this would be 1, 2 goes in, 3 doesn't, 4 goes in. See, 1 goes in 40, 2 goes in 20, 3 doesn't go in, 4 goes in 10, 5 goes in 8, 6 won't, 7 won't. Okay, so then 39. 1 goes in 39 and 3 goes in 13. Turns out that none of the factors here are in common. So the greatest common factor here is 1. Sometimes it's 1, or you could just say that they're relatively prime to each other. So you're going to be looking for greatest common factor in lots of things. Okay? Okay, well, as you'd expect in algebra, we don't just deal with numbers, we deal with variables. So if I wanted to find the greatest common factor of something, the first thing I need to know is how to break this down into all of its prime factorization. Well, the variables are easy. This is just A times B times B times B. And then I'd have to go over to the side and find the prime factorization of 12. Well, let's see. 2 goes in 6 and 2 goes in 3. So that's 2 to the second times 3. So the prime factorization is 2 to the second times 3. We're looking for the prime factorization. In other words, break it down into all of its parts. Okay? All right, let's go a little bit to something a little bit more complicated now. All right, we want to find the greatest common factor of 2 monomials. Remember, these are what we call monomials, and you found this in the last chapter. Well, the variables are pretty easy. This is just x times y, and this is x times y times z. So the greatest thing that's in common is a single y and a single x. So xy is going to be part of my greatest common factor. Now let's look at the numbers. Now we could break these down using prime factorization, or we could use just kind of racing around in your head. Well, one of the things I notice is that these are both divisible by 9. So 36 is 4 times 9, and 54 is, let's see, 9 times 6. But in 4 and 6 there's also a 2. So maybe this is the same as 2 times 9 and 2 times 3 times 9. So it turns out that there's actually an 18 in both of these. So we're looking for that greatest common factor. You may not realize it, but 18 does go into both of these, and the practice that you get on this. So I'm going to let it go here, but you're going to have to take a look in your book. If things don't have anything in common, you're just going to write 1. And if they do, then you're going to say what's in common to both. Go ahead and give that a shot. This first assignment is 9-1. Let's take a look at that assignment. All right, so your first assignment in this chapter is this happens to be assignment number 51. We're going to go by some numbers here now. 51. Assignment number 51. Yeah, 51. It's on the beginning of chapter 9. I'll be giving you a handout tomorrow, not today. But here it is. Go ahead and tackle this. Again, use your time wisely. When you seem to know what you're doing, move on to the next problem. There will be a chapter test at the end of this. So enjoy that. Take care.